Hello everyone, welcome to Instrument Hub. I am Bibin here. Today we are going to discuss about Vortex flow meter. This video describe about Vortex flow meter, how it is working, what is the principle of Vortex flow meter, and what is the configuration, and what is the parameter setting on the field. This all gather. It is the main HMI and monitoring unit, that means transmitter and cable has going below. There is a sensor. This is a main part of this transmitter, Vortex sensor. It is installed on between the line and we can see the nameplate of manufacturer. All data described on this nameplate, like what is the dia and what size and everything. And this sensor create the signal to transmitter via special specification of the cable, and there is a plug. The special cable connect below of the transmitter, and next we can see the principle.
Inside each vortex flow meter, a bluff body is located in the middle of the pipe. This body is a kind of obstruction that disturbs the flow. Downstream from the bluff body is a mechanical sensor which can register the tiniest pressure differences in the flowing fluid. If the fluid is not flowing, no vortices form. As soon as the fluid starts to move and reaches a certain flow rate, vortices gradually appear downstream of the bluff body. These vortices are detached alternately on either side of the bluff body and are carried away by the flowing fluid. Zones of high or low pressure now appear downstream and thus create a phenomenon that is known as the Kármán vortex street. These differences in pressure exactly match the frequency of the passing vortices and are precisely registered by the mechanical sensor, shown here in slow motion. This sensor is unique because it's inherently so well balanced that pipe-borne vibrations of up to 1 G, pressure surges, and temperature shocks have no effect whatsoever on the measurement. The distance between two consecutive vortices corresponds to a defined volume of fluid. Therefore, total flow can be calculated by counting the vortices that pass. The higher the flow velocity, the higher the measured frequency of vortices. In some applications, the velocity is too low for perceptible vortices to form. However, the velocity can be increased simply by installing a vortex meter that has a reduced cross-section. This modification does not affect the measuring accuracy. Functionality can be enhanced by incorporating optional temperature measurement into the sensor. A configuration like this.
A sensing element takes the mechanical motion generated by the flexure and converts it into an electrical signal. This electrical signal is then passed from the sensing element through a circuit up to the electronics board stack, where it is then processed and turned into a quantifiable velocity reading. This signal is then outputted to the Vortex's local display and out to the control system.
Configuration and parameter setting of Vortex flow transmitter I will going to include on next part because of video length. Keep watching on Instrument Hub, and thank you very much.